Hi guys, so this is what I got for today. If I click on a unit, the tiles that you can move to gets lighted up in blue. Now if I click on one of the tile that is in blue, it shows the path the unit is going to take to reach there, and we are using A-star algorithm to do this. Okay, so we got S, which is the starting tile, E, which is the ending tile, and X is like a wall and obstruction. And how the A-star algorithm works is it's got a G cost, and it is how many steps we have actually walked to get to a tile from the starting tile. So since we are already on the starting tile, the G cost for the starting tile is going to be 0, and we got a H cost, which is called a heuristic cost. It's a estimate of how many steps remain to reach the end tile. So if this has a coordinate of 0, 0, and the end tile has got a coordinate of 1, 2, 3, 4, and 4, 3. Yeah, so I'm already considering the orthogonal neighbors. So if I want to go to this tile, I'll either try going this way or this way. Not going to try the diagonals. Not going to go this way for now. So um, the h cost is 4 plus 3, 7, and the f cost is just the sum of these two. So 7. That's the f cost of this tile. Now from the starting tile, I can move either this way or this way. So the g cost to move one tile is 1, and h cost is going to be 6. So let's just let's say this has a coordinate of 0 comma 1. No, this has a coordinate of 1 comma 0. My bad, I always get that wrong. So that's going to be 4 minus 1 plus 3 minus 0. That's 3 plus 3, 6. So 1 plus 6, 7. The same here, got a f cost of 7. Now if I try expanding from this tile, since they both got 7, it doesn't really matter which one we approach first. So um, there's going to be 2 steps, 1 step, 2 steps, 2. So that's a g cost, and h cost is going to be 5. That's 7 again. Now if I try expanding this way, that's going to be 3 g cost, and the h cost is 4. We got 7 again. Now if I try going this way, so that's 1, 2, 3, and 4. 4 steps. So g cost is 4, and the h cost, the coordinate is 2, 0. So the h cost is 4 minus 2 plus 3 minus 0. That's 2 plus 3, 5. So h cost is 5, and this tile costs 9, which is not ideal. So we try this tile, which again has got a g cost of 4, and the h cost, this tile's got a coordinate of 3 comma 1. So that's 4 minus 3 plus 3 minus 1, 1 plus 2, 3, and we're back to 7 again. So we discard this tile, oh, discard this path and take this path because it seems the most promising right now. And we just continue. This is going to take a 5 steps, and this is just going to be 2. Again we go here, this is going to take 6, and this is going to be 1, so 7 again, and we finally reach the end tile using this path. So one thing worth mentioning is that A-star picks the shortest path. It doesn't necessarily mean it's going to pick the one you would have picked by eye, in case there are multiple shortest paths without any obstructions. So in my code, the tiebreaker is just whichever order the get neighbors method returns the neighbors in. Alright, time to look at the code a little bit. The core data structure is the open set. That's the list of tiles we still need to look at. Using a sorted set, which keeps everything in order automatically. When we ask for the next tile, we get the one with the lowest score. I'm also having a hash set that mirrors what's in the open set just so I can quickly check is this tile already in the open set. Sorted set is slow at that check. Hash set is instant. Two structures because I need both operations to be fast. We start by adding the start tile. We start by adding the start tile to the open set with its initial score. Then we loop. Each iteration we pull the most promising tile out. That's open set dot min. We check if it's our destination. If yes, we trace the path back and we are done. If not, we look at its neighbors. For each neighbor, we calculate what G score would be if we got the through this tile. Just current G plus 1. Then if we haven't seen this neighbor before or we found a cheaper way to it, then we know. Um, then if we haven't seen this neighbor before or if we found a cheaper way to it than we knew before, we update this info. We update G score. We compute the F score. That's an update and is how we find the F score as G plus H, and we add it to the open set if it's not already there. The case where we find the cheaper path is what makes A star discover like better paths or shorter paths. Um, if you initially reach a tile by going one way but later find a shorter route, the algorithm updates and the cheaper route wins. And we always remember which tile we came from. Um, that's this came from dictionary up here and so on until we hit a tile that has no entry in came from. Um, that's the start tile. We reverse the order and that's our path. And down here is a heuristic Manhattan distance, just the absolute x difference plus the absolute y difference, the estimated steps to end. And I click on a, oh, this is the scene view. So if I go here, game view, and hit on a unit, that's the tiles the unit can travel to. Now, if I click on one of these tiles again, that's the shortest path you can take to get to this tile. And if I click outside this mobile tiles, it just goes away like before. That's it. Yep, that's kind of it for today's video. Thank you.